We have a number of rules to follow when determining the Cahn, Ingold, Prelog CIP priorities. The rules are performed upon a molecule sequentially. So, Rule 1 is applied exhaustively to the molecule, and only if having analyzed the whole molecule and stereo descriptors cannot be discerned, do you move on to Rule 2. Then, only when the whole molecule has been studied by Rule 2 and no stereo descriptor can be calculated, you move on to apply Rule 3, etc. 1A gives a higher priority to a higher atomic number. 1B, the same atomic number found closer to the origin of the stereochemistry, has a higher priority. 2. A higher atomic mass has a higher priority than a lower atomic mass. 3. The Z double bond stereo descriptor has a higher priority than E, that has a higher priority than a non-stereogenic double bond. 4A. Chiral stereogenic units, so that would be capital R and S, are a higher priority than pseudo-asymmetric stereogenic units, small r and small s, and that is a higher priority than non-stereogenic units. 4b. Like stereo descriptor pairs, that would include RR, RM, RZ, MM, MZ, ZZ, are a higher priority than unlike stereo descriptors such as RS, RP, RE, ME, ZE, where E and Z are stereo descriptors for geometric stereoisomers, and M and P are stereo descriptors of helical stereoisomers. 4C. Pseudo-asymmetric stereogenic unit small r is a higher priority than its small s counterpart. And finally, 5. Big R is a higher priority than big S, and M is a higher priority than P. In practicality, when we look at popular databases of molecules that have been made, when applying CIP rules, about 98% use Rule 1A. So almost always atomic number will allow ultimately a stereo descriptor to be assigned when one can be assigned. About 0.1% achieve stereo descriptor through 4B, and about 1.5% through Rule 5 with big R and S or big M or P. None of the other rules individually exceed 0.1%. So, understanding the application of atomic number to Cahn, Ingold, Prelog rules is clearly important, and the other measurements less so, but they do very occasionally come up.